The merge sort algorithm is one of the most efficient algorithms when it comes to sorting an unsorted list. And it works with the split and the merge function. The split function divides a given list into two more or less equal child lists. And the merge function does the opposite. It combines two lists into one list, which contains every element of the two previous lists, but the elements will then be sorted almost perfectly. And we will try this with our 7 persons. First, we use the split method, which receives a list of 7 persons. These persons are unsorted elements, and the split function will create two lists out of this list. And now I have to zoom out a bit because we are going to need more space soon. Now we receive one list which contains 4 persons. And we receive another list which contains 3 persons after the split. And now we continue. Because as long as our created lists contain more than one element, the split will be recalled again and again. So now the method split is used one more time. And it creates 2 lists. One list contains the 2 persons on the right, and the other list contains the 2 persons on the left. And exactly like this, we continue with the other list. The number of elements in here is odd, so this split will create 2 lists. One list with 2 persons and one list with only 1 person. So for every list, we split again as long as they contain more than one element. That means for this list, we receive 2 lists which contain only one element each. And here we have a list which contains only one element, so it won't be split any further. And here we split up again. And down here we also split up. And now we only have lists which can't be split up any further. And when we reach the state, then we can merge the lists. And we will merge these lists in a reverse order than before. Everything which has been split up will be merged now. And during the merging, the sorting is performed. So we begin up here. we have split up this list into two child lists. And that's why these two will be merged now. This works like this. If I have only one element, then I create a new mutual list, and in the new list, the smaller person, which in this case is the one with the green pullover, is on the left and the bigger person is on the right. So like this. Now the smaller person is on the left and the taller person is on the right. And this list hasn't been split up. And that's why we don't merge anything there, and we continue with the next list. And this is also very simple to merge. We just have to ensure that the smaller person is on the left and the taller person is on the right. This is the case now. So down here, we do the same thing. We merge these two, and the smaller person has to be on the left, and the taller person has to be on the right. Perfect. Now we have 3 lists containing 2 persons each and 1 list containing 1 single person. And now we continue merging these lists. We have divided this list containing 3 persons into 2 child lists. So now we have to merge these child lists into one list containing 3 persons again. This works like this. We merge, and we are going to do this a bit better. I'm going to use 2 pointers now. And these 2 pointers point to the left element of each list that are going to be merged now. And we take a look which one of the persons on which the pointers point is the smaller one. The woman is probably the smaller one, so she's going to be inserted in the list first. Then she would be deleted. Then the pointer would move on. But the list doesn't contain any more elements, so every person from the other list is going to be inserted here. And here I don't have to consider anything when inserting the elements, because these 2 persons are already sorted. Now I have a new list containing 3 persons, and they are sorted according to their size. Okay, we had a list of 4 persons, which has been split up into 2 lists containing 2 persons each. And now we will merge these 2 lists into one list with 4 persons. And here we have to act the same way. The pointer is under the smallest person of each list, And we compare these two and we can see, okay, this person is smaller, so this person is inserted first. After that, she's going to be deleted. And the pointer moves on to the next person. And we compare the two persons again. And it seems that this person is smaller, and that's why it is inserted next. After that, the person is deleted and the pointer moves on. There are no more persons in this list. So the other two persons of the other list are going to be inserted into the new list. And now we have two lists, one with 3 persons and one with 4 persons. And we have split up a list of 7 persons in one list containing 3 persons and one list containing 4 persons. That's why we merge these two lists into one. And we are going to use the pointer again. We proceed like this. Again, we check which of the two persons on which the pointers point is the smaller one. And that would be this man in the red shirt. He's going to be inserted in the new list first and is deleted afterwards. The pointer moves on and we compare again. This man seems to be the smaller one compared to this woman. So he's being deleted and the pointer moves on. Now I compare these two persons and we can see this person is the next tallest. So this person is deleted and the pointer moves on. When comparing these two, we can see this man is taller, so he's inserted in the new list, is deleted afterwards, and the pointer moves on. When comparing these two, we can see that the woman is smaller, so she's being inserted in the new list, is deleted afterwards, and the pointer moves on. And when comparing these two, we can see that the man on the top is smaller, so he's being deleted and the pointer moves on. And now we see, oh, we don't have any more persons in the list, so every remaining person will be inserted in the new list. And the result is very good. We have received a new list in which all persons are sorted according to their size. And the complexity of the merge sort algorithm is n times logarithm of n, because we split up our quantity and we create partial quantities, and we have to check every one of these partial quantities so we have a complexity class of n times the binary logarithm of n.